Dear students, so far we have seen simply supported beam with the point load, simply supported beam with uniformly distributed load separately. Here we are going to see a simply supported beam with the point load as well as uniformly distributed load. So here the problem is given as a simply supported beam of span 10 meter carries two point loads of 20 kilonewton each at 3 meter and 7 meter from left support. Also, it carries a UDL of 12 kN per meter over a length of 4 meter at the middle of the beam. So first we have to draw a simply supported beam of span 10 meter and UDL, sorry, 2 point loads 25 kN each acting at 3 meter and 7 meter from left support. So from left support 3 meter 25 kN is acting, from left support 7 meter 25 kN is acting. That means between these 2 point loads the distance is 4 meter and the remaining portion is 3 meter. So again the next one is the UDL of 12 kN per meter of span 4 meter is acting middle of the beam. That means the total is 10 meter and middle of the beam means this is the middle of the beam. That means between 2 point loads the UDL of 12 kN per meter is acting. For this case we are going to solve the we are going to find the support reaction, shear force and bending moment. First we are going to find the support reaction. So two supports, two reactions, that is RA plus RB, that is RA plus RB equal to total load on the beam. Total load means 25 plus 25 50 and 12 into 4, that is 48. The total is 98 kilonewton. And the next step is taking moment about A. So taking moment about A, RB into 10, that is anti-clockwise moment, that is equal to 25 into 3. So and 25 into 7, you can see here 25 into 3, 25 into 7 and UDL 12 into 4. So UDL and its length 4 meter, that is the total load. 12 into 4 is the total load where it is acting half of the 4 meter, that is 2 meter, that is 2 meter from here, but we are taking moment at A. So from A point the UDL acting point is 3 meter from 2 meter, that is 5 meter. Here we can see 12 into 4 into 5. So 12 into 4 is the total load. That total load is acting half of the 4 meter. That point is 5 meter from A, that is 12 into 4 into 5. If you solve this, we'll get the value of 49 kilonewton reaction. Reaction at A is 49 kilonewton and reaction is B also 49 kilonewton. Why the both values are coming same? Can easily see from A 3 meter 25 is acting, from B 3 meter 25 kilonewton is acting, and center of the beam we are having 12 kilonewton per meter for a length of 4 meter. So since this is the symmetrical section, you can split the beam into two half at the center. Both left and right are same distance, same load value, everything is same. That's why we are getting same reaction. That is RA equal to 49 kilonewton, RB equal to 49 kilonewton. So we can easily, as we have already practiced more problems, we can go with direct. So we can find the shear force at A at the, that means that the 0 meter of the beam. So plus 49 kilonewton. Shear force at 3 meter plus 49 minus 25 will get plus 24. Shear force at 7 meter uh, uh, we have to find if a point load is acting at the end of the UDL, we have to find two values, that is without considering the point load, with considering the point load. First we have to find without considering the point load. that is plus 49 minus 25 minus 12 into 4, that will give minus 25, and again we are adding minus 24, again adding the point load, minus 24 minus 25, we will get the value of 49. So you can see minus 24 minus 49. So at the 10 meter, that is end of the beam, the value is 49. Okay, we can easily draw the shear force diagram. So you can see upward reaction, no force, downward point load, downward UDL, downward point load, no force, upward reaction. Here the 49 minus 25, this one is this one is plus 24, and this one is minus 24. This point is minus 49. This point is also minus 49. You can easily draw the shear force diagram. And for bending moment, at A the value is 0, and also B the value is 0. That is no distance in the left of A and no distance in the right of B. You can see at the support point bending moment value is 0. At the 3 meter, you can see at 3 meter moment is equal to RA into 3, that is 49 into 3, 147. At 7 meter, RA into 7 and 25 into 4 meter, and 12 into 4 into 2 meter, and if you put together you will get the value of 147. So both values should be equal because the beam is symmetrical. So if you draw, so here the point load, so inclined line, here is also point load inclined line. So but between these 2 points UDL is acting, you have to connect these 2 points, that is 147 147, by using parabolic line. This is not inclined, this is parabolic. Since this is a parabolic line, you will get the maximum value here. Where will be the maximum? Where the shear force value is 0, bending moment will be maximum. Where the shear force is 0, it is at the center of the beam. Center of the beam is 5 meter from the left support. So you can see at 5 meter, middle of UDL, that is middle of the beam. So at the center, you have to find the bending moment. So from the left, so 49 into 5 minus 20 into 2, and 12 into 2 into 2 by 2. We will get the value of 172. The maximum bending moment is 172. So we can easily find out the maximum bending moment, and also we have drawn the bending moment diagram. So this diagram will use the three-dimensional diagrams for your reference. The same problem. So you can see the hinged support, roller support. Also you can see the shear force diagram as well as bending moment diagram in the 3D. Hope you are all understand this problem. We will see in the next class.